Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we will start our journey in the lighting system design. So this is a very important tutorial because we will discuss some important basics that will be the core of this section for anyone who wanted to understand how to design any lighting system. So fasten your belt and let's get started. The aim of this tutorial is to learn some basics related to the difference between the interior and the exterior lighting system designs, and also we will discuss some definitions related to the lighting system in general. So let's go ahead. The first basic question now is that, what is the first step of any lighting system design? And here the answer is that when we start any design for any lighting system, we must know firstly what is the nature of the place that we need to make the design for it. So we need to specify firstly the type of the place. And for that we have two kinds of places that we need to make the lighting system for them. The first one is called the interior design, and the interior designs are some designs like that home here in that figure. And the second type is the exterior lighting system design, as you see here, this design for the outdoors. So according to the type of the lighting design, we will specify the steps of the design. And this is because the steps of the outdoor designs are different from the steps of the indoor design. For example, there are some lamps that are used outdoor, but we don't use them indoor. Also, there are some lamps that are used in the interior design, but we cannot use them for the exterior design. This is because those lamps are designed mainly to be used for the indoor design, not the outdoor. So if we specify the type of the design to be interior or exterior, the next step will depend on that type. Alright, now let's start with the interior design. As we said, the interior lighting system design is any design that is located inside the building in case of closed buildings. So for any closed building, the lighting system design for it will be an interior design. And an example of that is that mall here. And also if we are making the lighting design for this closed basketball court, so this is an interior design also. And the same thing if we made the lighting design for this lecture hall, so this is another example for the interior design. Alright, now let's go to the second type, which is the exterior lighting system design or the outdoor design. Here its definition is the inverse of the interior design, as it's any lighting design that is located outside the building in case of closed buildings. So for any closed building, any design that is located outside it will be an exterior design. And an example for that exterior design is the parking outside the mall, for example. So the street lighting outside the mall is an exterior lighting design. But we have another definition for the exterior lighting design, which is any lighting design that is located inside the building in case of open buildings. So for the open buildings, any lighting design inside it will be an exterior design. For example, the lighting design for the football stadium, it's an exterior design. This is because it's an open building, although the design is inside it. And also if we have an open basketball court, so its lighting design now is an exterior one. This is because it's an open area. While if you remember on the previous example, the basketball design was an interior design. This is because the basketball court there was in a closed building. So according to our case, we specify the design type. Very good. Now let's jump to some concepts related to the lamps that we will use in our design. So the first definition we need to discuss now is the luminous flux. So the luminous flux is the quantity of light emitted by the light source for a period of time, and its unit is lumen or LM. So if this is a light source, so the quantity of light that is emitted by that light source for a specific period of time is the luminous flux. And its mathematical relation is that one. Here the sample of the luminous flux is phi, and it's equal Q over T, where Q is the quantity of light emitted and T is the period of time that this quantity of light is emitted at which. So this idea of the light emitted is similar to the water that is going out of the faucet, as the water represents the light or the Q in our example that is going out of the lamp at specific time. So there is a faucet that has a large amount of water going out of it, while another faucet permits a small amount of water to go out of it. So the lamps have the same idea, as each lamp has a fixed value of lumens that it can produce. So some lamps have a smaller value of lumens emitted out of it, and some other lamps have a higher value of lumens emitted out of it. Very good. Now the second parameter related to the lamps is called the illumination or the lux of the light source. So the lux is the number of lumens falling on the surface per unit area. So we can say that the illumination is the relation between the lumens emitted from the light source over the area that those lumens are falling on. So the illumination is represented by the letter E, and it's equal phi over A, where phi is the lumens that we have just talked about, and A is the area that those lumens are falling on. So suppose that we have that light source that emits some amount of light. At that condition, the lux or the illumination at that surface will be 2000 lux, while the lux at that larger surface will be only 500 lux. And you can notice, although we have the same light source, but the illumination is different from the first area to the second area, and this is because the lux depends mainly on the area that is falling on it. As when the area increases, the lux will decrease. This is because the lux equal phi over the falling area. But you know, the illumination can be determined also at a specific point, not at a specific area. So if we need to calculate the illumination at a specific point, here its relation equal I times cosine theta of the power 3 over h of the power 2. I know that you don't understand anything from this relation until now, but we will break it into some simple pieces to understand it. Here I is the amount of light emitted from the light source, and it's similar to the lumens, but it's another parameter here that is called the lumens intensity, and we refer it to the letter I. And this I or the lumens intensity is an expression of the amount of light that is emitted from the light source. And also its unit is candle, so we measure it with a unit of candle. So this is about the first parameter I. And then h is the vertical distance from the light source to the surface at which we need to calculate the illumination or the lux. And then theta is the angle between the vertical line and the line that connects the light source to that specific point that we need to get the lux at it. So if we need to get the lux at that point, it will be the candle emitted from the lamp times cosine theta of the power 3, where theta is the angle, as you see, between that vertical line to the light source over h square, which is the vertical line here. But this is about the mathematical point of view. And now we need to know practically what is the difference between the illumination or the lux and the luminous intensity phi. So we need to know for our design that we will implement what is the difference between E and phi. Now suppose that we have this light source on that sleeping room. So the lux at that condition is the amount of light required to exist in the working plane. So each type of places or each room will need a specific value of lux to exist on. And we get this value of the lux from some standard codes like the IEC code, and this is a screenshot from an international code of the lux that is required for some places. As you see, the general office, for example, needs 500 lux, while the business machine office needs 750 lux for it, and so on. So those are the required values of lux or lumens to fall on the surface per unit area. But on the other hand, the luminous flux or the phi depends on the lamp type itself, regardless to the type of the place that we need to design the lighting system for it. So it's the amount of light emitted from the lamp itself. And we get this value from the lamp datasheet, as the lumens are specified in each lamp datasheet. You can see here each of those lamps has a fixed value of lumens of 1600 lumens, so we get the lamp lumens from the catalog of the lamp, as it's considered as a specific feature of each lamp. But you can see also, although each lamp produces 1600 lumens, but the first lamp consumes the largest power of 100 watt, while the second lamp consumes only 77 watts, and the third lamp consumes 23 watts. And lastly, the last lamp consumes only 20 watts. So this leads us to another concept, which is the lamp efficacy. So the lamp efficacy is the ratio between the input power of the lamp to the output lumens that is going out of the lamp. As each device has an input and it produces an output, so the input of the lamp is the power in watts, while the output of the lamp is the light in lumens. Or in other words, the lamp converts the electric power to a light output of it. So the efficacy of a lamp is the ratio between the input power to the output lumens. And by that value, we can specify the efficacy of each lamp. For example, we can have an incandescent lamp that consumes 40 watts and it produces 55 lumens. So its efficacy at that condition is only 14. While another compact fluorescent lamp can produce some lumens of about 550 watts, but with an input of power of 9 watts only. So it's very obvious that the compact fluorescent lamp is more efficient, as its efficacy is larger than the incandescent lamp, as here it's 61. On the other hand, another LED lamp can consume only 7 watts, but it produces 400 lumens. So its efficacy at that condition is 75 lumens per watt. So what we want to say is that the higher efficacy, the more better is the lamp. More than great. So that's about this tutorial. Hope that's clear right now. Thank you for watching and see you next tutorials.